So it's time to look at input. The way SDL deals with input is by events. That is, we can have keyboard events, mouse events. We've talked about this. Events like, mouse buttons being clicked or released or the mouse moved. It can be keyboard keys that are pressed or released. It can be touchscreen events. It can be network events. It can be your sound card running out of a buffer or a timer going off. These are all events. And all events in SDL end up in a single queue, which we pull every frame to check if there is anything standing in the line waiting for us to look at it. So basically, every frame we have to pull for events, see if any of them are events that we care about, and then deal with them. That's the basics of event polling. So if I do SDL event, let's see if there is a function for this. Maybe poll event. Yes, indeed. So let's go look at the documentation for that. SDL poll event, yes. So what we see is it returns an integer, which tells us if there is an event or not. If there is, it will be 1. If there isn't, it will be 0. So that's cool. That means we can put this directly into a loop to spin for as long as there are events in queue. We also see that it takes a pointer to an event struct. This means a pointer is an address to an event struct. A pointer is an address to something in memory, in this case, an event struct. So we're going to send in an address of an event struct. No big deal. And because it's not const, we know that this function is probably going to manipulate, that is, change this event struct. It's going to set the values inside of it so that we can use it after we have called poll event, passing the event in. Here's some sample code. Indeed, while poll event sending in the address of the event. So what you notice here is that they're spinning forever, and for every time we go through this loop, they create a local event struct here, and then they call SDL poll event, sending in the address of that event. The ampersand is the address of operator. So in the same way, a reference that we've been using to pass parameters, a reference is just the address of your original object. This is exactly the same thing. We're passing in the address of this local event so that the poll event function can manipulate it, and then we can read from it here. So that's cool. That's easy enough. We need to do some restructuring here, because we are going to have to check the event queue repeatedly. There's no point in doing it once. You have to do it frequently as possible, in fact, to make sure that your application is responsive to the user. Right now, just to show you what type of events we might want to deal with, if I run my application, it will display the window for two seconds. And if I click over here at the X, nothing happens, right? It will run for 2 seconds no matter what. That's the type of event we can listen for. That would be the SDL quit event. So we're going to need a function. Let's call it, it's a void function. Let's call it check events. Let's call it check inputs instead, because inputs is the type of events we actually care about. And it will match the model of a core game loop that we talked about a couple of lectures ago. So check inputs. We need a local event, an SDL event. Let's call it E. And then I want a while loop. While there are events in the queue, fill our event in with all that information. And then we want to do something with it. So the SDL event struct is created so that it can hold all the types of events that SDL generates. So if you type out the name of that little variable and then press the dot, you will get some tooltips here with all the different values this thing can have. The one that is safe to use to begin with is the type. We want to know exactly what type of event we have been given. That will allow us to parse the rest of it. Right now, we are going to check for if the type is SDL quit. And now I just want to make sure that this is in fact the event I'm thinking and not, say, a function definition or something else. I'm just going to go to the definition and look. And indeed, This is part of the definition for events that can be delivered. So SDL quit, useful one. We might want to scroll through here. Also, you can just check the documentation for other useful events, but say key up and key down, super useful. Mouse motion, mouse button up and down, super useful. The scroll wheel, also useful. Obviously, all the events are useful, otherwise they wouldn't exist. But those are some we might want to care about, in fact. So let me add those to a comment here to look for later. We want to look for SDL, actually, I don't remember. Key down, SDL key up. Heck, we might as well work this out. So else if eType equals SDL key down. We might want to do something with that. To do. Else if. Now, using else if like this is doable. You can also use a switch statement here, of course. A switch statement would be slightly faster. So you would switch on the type and then use these as cases. Either way. We don't care about that right now. So this is our quit. So how do we quit? Right now it quits automatically. And we are not calling this repeatedly. And also we can't call it from main because it's underneath main. So we need to move the declaration of the function up above main. Let's start with that. There we go. So now it's defined. We can call it from main. So let's see. We want to have something like while is running, check inputs, that's the function we just wrote. Then we want to have like render. No, sorry, we want to have update game objects here. This would be the layout for a core game loop. Update game objects and render game objects. Actually, just render everything. We don't care so much. And then basically do it all over again until it's time to quit. So is running should be a Boolean value. Should default to true, so the game is running by default. But then how do we set it false from check inputs? Check inputs could, of course, return a value, say true if it should continue running, but that would make that function fairly limited and a bit dumb. Like there's no reason for a check input to return anything. And if SDL quit returns true or false from this function, what do the other events return? Like if a keyboard is pressed, the keyboard button is pressed, what are we meant to return from this function? Is that a true or false? I mean, you'd want to know what type, what key was pressed and what the state of it was. So let's just put it this way. This function should not have returns, at least not right now. So the correct, or one way of doing this is to make is running a global variable. I'm going to move it out of main. Remember that is running because it's declared and initialized in the main scope. It's not visible outside of the main. Main ends here, right? So when we call check inputs, it's no longer visible. We'll be stuck in this while loop. Whatever. So let's move it out of main to make it visible. And when I move it out, I'm also going to rename it. So now it's called underscore is running. So that's a pattern I use to indicate the scope of member variables and global variables. Basically, anything that is not local to the function will have an underscore. If you worked with Java, this would be m is running for calling it a member. This is not necessary, but it helps a lot because it tells me immediately at a glance that this variable is defined outside of this function. I'm not going to find, it's not a magical value. It's not a name out of nowhere. Rather, it is, but I know it's meant to be. It's not like I forgot to initialize it in this function. So now it's accessible inside main while it's running. And it's also accessible from check inputs. So if I go down here in SDL quit event, I set is running to false. So if the event that we just received is SDL quit, we set is running to false. Then this loop will keep spinning until we're out of events. We'll go back to the main loop. We will update game objects, we will render, and then when we come back up here, it will quit. So this means we should move a bunch of code sort of into this loop, because otherwise, well, we will just be stuck here until we quit. We won't actually render anything. So at the beginning of each frame, we want to clear the buffer. And we want to present whatever was drawn in between there. And we should probably take this delay with us as well. Otherwise, we will spin as fast as this loop goes. So I'm going to bring that into the core here. Let's remove those comments. The delay is now 2000 milliseconds, and that's a bit much. That means we will only check for that event every 2 seconds. So if I bring this down to something reasonable, like 16 milliseconds, that's what you get if you divide a second with the number of frames per second we want. So basically, a second is 1000 milliseconds. We divide that with 60 frames per second. You end up with 16.6, which is not something we can store in an integer. So I'm going to do this. Just add a comment to explain what these values are. Something like that, just to tell us why I put this value in here. So if I'm targeting 60 frames per second, 16 milliseconds is how much I need to wait every frame for that target frame rate. If you don't have the delay here, your CPU will spin at 100%. It will be entirely busy all the time. That's fine. It will, shorten your battery life and it will heat up. You will hear the fan spin. So I'm basically delaying just so that my computer can last longer on battery. So now we are spinning forever until I click the X. And there we go. We've dealt with an event. Next up, we might want to try some, well, we're going to have to refactor here soon because now this function is getting crazy. We're not doing error checking properly. And we want to basically, at the end, we want to have something like setup outside of that loop. We want to have teardown, and we want these to be functions pretty much. Then we want render here, and we want update to be a function, so that at the end of our refactoring, this is all that's in our main. We have the setup, we have the core loop, and then we tear down after we are done. That's all we need in main. We should move everything into functions that we have in here so far. But we'll do that over a couple of videos. Let me bring all of that back. Let me double check here so I didn't break anything. Yeah, that's good. Cool. So I'll see you in the next video.